Welcome everyone. Today we're going to be talking about specifically functions, but in that we're going to be talking about functional notation, which is something that's really prevalent in both Algebra 1, Algebra 2, and definitely the SAT. So today I'm going to be going over the parts of a function, really understanding what functional notation is, and then giving you a technique in which you can solve any functional notation question that you come upon throughout the SAT. And any functional question during your Algebra 1 or Algebra 2 class. So let's get right into the session and see how things go. So let's just start off with a equation in functional notation. So let's just say that f of x is equal to 3x squared plus 2x plus 5. Alright, so here we see, let's try to make sense of it, and here we understand that we see this f of x term as some type of singular term. It seems like this x term right here is kind of like throughout the function, and it seems that it's being combined with other terms to form this f of x term. So I'm thinking of this and looking at, well, it seems like f of x is this type of final product, and x is this type of initial type of thing that's maybe put into the function. So, all right, let's try to define this and see if that makes or helps us make sense of this. All right, so let's just start off with f, which I think is a great way to start. It seems that f is the name of the function. All right, then let's go with x, the x term. It seems that it is the input. All right, so if it seems like the input variable, what would f of x be then? It seems f of x is simply the output value of f when the input is x. And I think looking at this like this, with the definition, with these words, really makes us understand and helps us understand what exactly is going on. We see that f is definite, is like the name of the function, right? We see that when we put a term in here with x, we will get this output value of f when the input is x. So, wow, this actually makes a lot of sense. I hope it makes sense to you too, because I think that with this definition, I'm able to understand exactly what's going on here. So before we continue, I just want to make note that it's very important to memorize these terms that I've listed over here, because it's very important to understand the fundamentals of each concept, because when we go into the more dynamics of it and more, I would say, not hard examples, but conceptual examples, it 100% helps. So this technique is built off of this concept that I've explained with these definitions, so it is very important to understand. So let's get right into the technique. So whenever we're solving, whenever we're solving any type of functional notation question on the SAT or in your classroom, we really have to find, it's usually to find the output value of a function at any or a given input. So I'm going to warn everyone that my technique here has a little bit of humor in it, so don't be surprised when you hear some things that you might not expect. Alright, so the first step in my technique, in this technique really, is to turn off your brain. What I mean by that is just forget everything. Okay. Secondly, what I want you to do is replace every instance of the input, which we've defined x, variable in the function definition with the input value you have been given, right? And now you can turn your brain off. Again, this is figuratively, and it's a complete joke. It just basically means to not think too much about anything but replacing every instance of the input variable with the definition of the input variable. And then just solve it. Okay. Alright, so let's try to look into this and understand what's going on. We're first of all not worrying about anything. We're replacing every instance of the input variable, so that's interesting, input variable, with the function's definition of it. And then we're solving it. Simple. Okay. And for a lot of you, let me just shorten this down and put it in the corner so we can look at a nice example. For a lot of you, oh, it's not coming up. Let me just make this. Okay. Sorry, guys. I just need to find some room to write the example down. But it seems that all we have to do is replace every instance of the input that we have and solve at the end of the day. So it might seem very, very simple, but when we look at more complex examples, it's something that makes us feel that is something that we kind of forget. So let's just look at this example. This is an SAT level question. F of x is equal to h minus 3. Sorry about this. It's kind of confusing. Is equal to x minus 8, x minus 4, x plus 1 squared, which is equal to 0. So in this question, it tells us that x is equal to h minus 3. So let's just try to use this technique that we have. So we just forget about everything, then replace every instance of the input variable in the function's definition with the input variable you have been given. So our input variable is h minus 3. So let's just try to plug it in. F h minus 3 is equal to h minus 3 minus 4. Okay, and then we see h minus 3 plus 1 squared. All right, so let's just now solve. So it seems to be h minus minus plus, so plus 7, h minus 2 squared is equal to 0. So it seems if we simplify all this down, h is then equal to 7 and 2. It's interesting. So I think that we have just found the answer to something that may have been very, very complex to us, but understanding that all we have to do is replace every instance of the input variable with the definition of the input variable that we have been given. Statistically speaking, before we end today's session, on the SAT, and I believe in Algebra 1 and Algebra 2, but definitely on the SAT, function notation questions are missed a lot, and statistically, they're very hard. But with this definition, with his equations, and with all this stuff going on, in reality, they're very easy. I hope you found this session useful. If you did, please give us a like. Thank you for watching. Until the next one. Adios.